If you look in the glossary of your grade 9 textbook, you're going to see over 200 terms, but in this video, we're going to go over the 40 terms that actually matter for you to be successful in the class. And this starts with the basics of algebra. The very first term we're going to cover is, well, variable. And a variable is a letter that represents a number we don't know yet. So let's take a look at this expression x plus 4. Well, we don't know the first number, so we let it be x, and x is the variable. Next, we have expression. And an expression is just math without an equal sign. So here we have 3x plus 5. There's no equal sign. An important tip to remember is that you simplify expressions, but you don't solve them. Speaking of solving, next we have equation. And an equation has an equal sign, so consider 3x plus 5 equals 20. We can actually solve these ones, unlike expressions. The next term is coefficient. Now a coefficient is the number in front of a variable, so consider the expression 7x plus 1. Well, 7 in front of the x is the coefficient, and it tells us how many x's there are. Next we have constant. A constant is a number without a variable, so consider the expression 4x plus 8. Well, 8 doesn't have a variable attached, so in this case, it's constant. And this means that as x changes, this value won't change. Feel like you got a good grasp on it so far? Let's continue. Like terms. Like terms are terms that have the same variable and exponent. So looking at 3x and 5x, they both have x's and they have the same exponent, and therefore they're like terms. However, 3x and 3y do not have the same variable, and therefore they are not like terms. Next we have solution. Now the solution is the value that makes an equation true. So the equation x plus 5 equals 9 has a solution where x equals 4 because that's the x value that if I plug it in, makes the equation true. Speaking of plugging in, the next term is substitute, and substitute means to plug in a number for a variable. So here we have 3x plus 4. If I'm told that x equals 2, I can now substitute it into the expression as the x. So 3 times 2 plus 4. And now I can solve. The next term is to simplify. A lot of times students don't know what this means, and it causes them to lose easy marks. Simplify just means to make something as clean as possible. So here we have a messy expression, 6x minus 2x plus 4y plus 3y. Well, I have like terms, I have 2x terms, and I have 2y terms, and if I combine them, so 6x minus 2x is 4x, and 4y plus 3y is 7y, I've cleaned up the expression to look like 4x plus 7y, which is simplified. Now, not to be confused with simplify is evaluate. Evaluate means to substitute in and calculate. So here we have an expression 4x plus 7y, and if I'm told x equals 2 and y equals 3, I can substitute them into the equation as x and y and evaluate to solve. So here I have 4 times 2 plus 7 times 3, which is 8 plus 21, and obviously that is 29. All right, let's get into some of the harder stuff, and this is found with linear relations and graphs. Starting with, well, linear relation. A linear relation creates a straight line when it's graphed. So it could look something like this, y equals 2x minus 3. And you can see on the right, it's a straight line. Normally, these linear relations will have two variables with no exponents on either one. The next term is an independent variable. Now, the independent variable is the input into an equation, and it's usually x. So here we have y equals 4x plus 3, and x is the independent variable. An important tip is that you choose the independent variable's value. Now, the reason you choose it is so that you can solve for the dependent variable, and the dependent variable is the output, and it's usually y. So in the equation y equals 4x plus 3, y is the dependent variable, and an important tip is that you calculate the dependent variable's value based on what the independent variable you chose was, and you just solve for y. Next we've got slope. Slope tells you how steep a line is, and it follows a general equation of slope is equal to rise divided by run. So here we have a graph where you can see the rise is in green and the run is in pink. I can calculate this by counting the squares and see that rise over run is equal to 6 over 3 or 2, and so my slope is 2. Now on the right hand graph, I have a smaller rise and a larger run, and so this time my slope is equal to 2 over 6 or 1/3. The bigger the slope, the steeper the line, and the smaller the slope, the flatter the line. Next we've got rate of change. Rate of change is literally another way of saying slope. So if slope is equal to rise over run, many times we let rate of change be y2 minus y1 over x2 minus x1, but they're the exact same thing. As you get further in math, rate of change becomes a little bit more complex, but for now they're very interchangeable. The next term we're going to look at is the x-intercept. The x-intercept is where the graph crosses the x-axis. So here we have a graph, and you can see a line that goes over both the y and the x-axis. Well, this point right here where it touches the x-axis is the x-intercept. Now, an important tip is that at the x-intercept, the y value is always 0. Next, we have the y-intercept. The y-intercept is where the graph crosses over that y-axis. And so here we have our graph, the same graph, except this time the y-intercept is where it crosses over the y-axis. An important tip is that at the y-intercept, the x value is always 0. The next term we have is the table of values. So a table of values shows all the matching x and y values. So consider the equation y equals x plus 3. Well, there's a bunch of x and y values that make this equation true. And if we put all of those into a table, well, that's my table of values. Moving on to the Cartesian plane. The Cartesian plane is the grid that's used for graphing. And so here we have a graph. It's got a vertical or an up and down y-axis and a horizontal or a left to right x-axis. Now, what do we do with the Cartesian plane? Well, we use it to plot ordered pairs. An ordered pair is simply written as x comma y. So if we have our Cartesian plane, you can see all of the x values are labeled -3, -2, -1, 1, 2, and 3. And same with the y values. Up is positive, down is negative, and for x, left is negative and positive is right. So if I take the ordered pair 3, 2, this would mean the x value is 3 and the y value is 2, and you can see it on the graph right there. Similar for -2 and 1. The x value is -2 and the y value is 1. -3, -3, both x and y are -3. You see it in the bottom left. And then finally for 1 and -2, I have an x value of 1 and a y value of -2. Again, an ordered pair will always be written as x comma y, or independent variable comma dependent variable. If you've been keeping up so far and you know these terms, you're in pretty good shape. Let's see if you know the second half. Next, we have the origin, and the origin is just the point 0, 0, and it's right in the middle of the Cartesian plane. Now, an important tip is the origin is where the x-axis and the y-axis meet. Now, for graphing, something that's really important to understand is the scale. And the scale just tells you how much each square on a Cartesian plane is worth. So here's two graphs, and the one on the left, you can see the scale is 1. Every square is worth 1 value. However, the square on the right, you'll see each square is worth 2. And this scale matters when you're plotting your points. So you always have to be careful to watch for it to make sure you're plotting accurately. The next term we can have might sound tricky, it's domain, but it's actually really easy because the domain is just all the x values in a relation. So here we have our table of values again, and all the x values, well, that's the domain. Similarly, we have range, and the range is just all of the y values in a relation. So with the same table of values, it's just all the y values. That's the range. Now, if you're looking at a graph, sometimes there's a trend, and a trend just tells you whether the data is increasing, decreasing, or staying constant. So look at this Cartesian plane. If your graph is moving up and to the right, it's increasing. If it's moving down and to the right, it's decreasing. And if it's moving in a perfectly horizontal line, it is remaining constant. Now, this next term sounds trickier than it is. It's interpolation. Now, interpolation means you're estimating between known data points. So consider a graph where I know a bunch of points, and you'll see them here in blue. Well, I can interpolate based on the pattern I see that there's a point right here. It's not given to me, but based on the data and the pattern I see, I can assume it's there. That's interpolation. Let's move on to something that a lot of people struggle with, and that's geometry. The first terms might seem a little easy, but we'll get to the harder ones. The first term is area. Area is the space that's inside a shape. So here we have a blue rectangle, and this light space on the inside, that's the area. Now, an important tip is that the area is measured in squared units. Next, we have perimeter, and perimeter is just the distance around a shape. So here we have a red rectangle, and if I were to calculate the length of that red line going all the way around, that's the perimeter. The next term is volume, and we're not talking about audio here. In math, volume is how much space a 3D object takes up. So here I have a 3D prism. The area inside this box is the volume. Now, an important tip is that the volume is measured in cubed units. Now let's take a look at some of the terms to do with a circle, starting with radius. And the radius goes from the center of a circle to the edge. So here we have our circle. If we go from the center to the edge, that's the radius. On the other hand, the diameter goes from one end of the circle to the other, but it must go through the center. So here we have our circle. And if we go from one end to the other, going through the center, that's the diameter. And it's always the radius times 2. The next circle term we have is the circumference. The circumference is the distance around the circle. So if I have my circle, the circumference is this distance around in green. And it's basically the perimeter of the circle. We just have a special name for it. The next term that you need to know is the Pythagorean theorem. Now, the Pythagorean theorem is a squared plus b squared equals c squared. So here we have a right triangle. You can tell because of the little square in the bottom left corner. We have A and B, which are on the sides that are touching that square, that 90-degree angle. And C is on the hypotenuse, which is always on the opposite side of the triangle as the 90-degree angle. Now, an important tip for this is that it only works with right triangles, because if it's not a right triangle, it doesn't have a hypotenuse, and so there can't be a C value. That's an important tip that a lot of people mess up on, so don't be one of them. Now let's go to an area of math a lot of people struggle with, and that's probability and exponents, starting with sample space. The sample space is all the possible outcomes. So let's say you have a die and you roll it. If you roll that die, how many different outcomes are there? Well, you could roll a 1, 2, 3, 4, 5, or 6. And those are the only possible outcomes, but that's all the possible outcomes, and therefore that's the sample space. Now the next term is favorable outcomes. Favorable outcomes are the results you actually want. So let's go back to our dice example. If I roll the die, I could have a 1, 2, 3, 4, 5, or 6. That's my sample space. But what if I wanted to roll an even number? Well, now my favorable outcomes are 2, 4, and 6, which is only half of the outcomes from the sample space. Therefore, I have a 50% chance of a favorable outcome. The next term is theoretical probability. Theoretical probability is what should happen mathematically when an event occurs. So let's flip a coin. Well, theoretically, 50% of the time you're going to flip heads, and 50% of the time you're going to flip tails. But we know that doesn't always happen. And that leads us to the next term, experimental probability. Experimental probability is based on actual results from trials. So if I flip a coin 6 times and I get these results, I get heads, tails, 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 heads, tails. We expected 50-50, but in reality, we got heads 1/3 of the time and tails 2/3 of the time. That's experimental probability. The next term we have is base. When we have an exponential term, the base is the number being multiplied in an exponent. So here we have 3 to the power of 5. The big number on the bottom is the 3. It's the number that's going to be multiplied. Now, on the other hand, we have the exponent, and the exponent tells you how many times to multiply the base by itself. So again, with 3 to the power of 5, the exponent is the small number in the corner. That's, in this case, 5. And this means that we multiply 3 by itself 5 times. Now, the final term we're going to cover in this video is exponent laws, and there's 3 of them. Exponent laws tell you how to simplify powers. The first exponent law is when you have 2 exponents that have the same base but different exponents, you can just add their exponents. Similarly, if you divide 2 numbers that have the same base, you can subtract their exponents. And finally, if you have a base to the power of a power, all you need to do is multiply the 2 exponents together. I hope you found this video helpful, and let me know in the comments if you knew all of these terms. If you did, you're in really good shape to do well in the class. Good luck.